Hello everyone, welcome back. This is the Calculus 3. In this video, we are going to talk about 2.4, the cross product. So this is a different from the dot product. So I will show you the difference between dot product that we learned in 2.3 and 2.4, the cross product. So if you remember the dot product, we are literally, multiplying two vector system. And then if you have a u vector, let's say u1, u2, u3, this is a u vector, and v vector, v1, v2, v3, dot product u dot v, that means u1 times v1 plus u2, v2, and then u3, v2, all the summation of the products of the entities, the corresponding entities. So that was a dot product. What is a cross product? Okay, so cross product, it's a totally different from the dot product. So we're gonna introduce the cross product, but still we're gonna find out the product of two vectors. And then in this time, we are going to generate a third vector we call orthogonal, that is to which is a perpendicular to the given two vectors. So for example, sounds a little bit abstract, but I just want to say that dot product is not equal to cross product. So cross product, to understand, let's take a look at that image. I have a u and v vector, right? So u is going to this direction, v, we have that direction, and there's an angle that they're creating. And then let's say there's another vector we call w, okay? So when I look at the characteristic of the w vector and u vector, when you look at those two vectors, they're going to creating the 90 degree, okay? And then when I look at the w vector and v vector relationship, they're also going to create the 90 degree perpendicular. So in other words, if you multiply u and v, right? And then let's say that is w. If w is going to be perpendicular to each given u and w vector, we call that is a third vector orthogonal. Does it make sense? Third vector orthogonal to first u and v vector. So therefore, what mathematical relationship is going to be created? U and w vector that is going to be orthogonal. Mathematically, u times w must be equal to 0, correct? Same thing, v and w is orthogonal. That means v times w is going to be the 0. So if you can find out this unique vector w, and then this is the multiplication between u and w, u and v, the given two vector. And then if you can find out the 90 degree, this is how we are going to find out the orthogonal relationship among u, w, and v. Okay, so and then that multiplication we call cross product, which is different from the dot product. Dot product, we are just literally dealing with two vectors, and then you can find out the summation of the product. Cross product, we're going to find out the third vector that is perpendicular to each u and v, and that multiplication I'm going to show you, we call that as a cross product. So therefore, mathematically, this two equation is going to be satisfied. Okay, so let me read it the definition one more time. In this section, we introduce the product of two vectors that generate a third vector orthogonal to the first two. Consider how we might find such a vector. Let the vector u and v, and then let's say they are non-zero vector, and then you can find out the unique vector w by multiplying those u and v, and then if you can find out the perpendicular relationship, that's how we're going to find out the third vector. Okay, so let me show you more mathematical work. So I already have a space, so let me show you more work. Here we go. So cross product implies that cross product implies you have U times V equal to W, and then U and W perpendicular, V and W perpendicular. And then mathematically perpendicular means U times W equal to 0, and then V times W equal to 0, because that's what the perpendicular, creating 90 degree. So let let W vector is XYZ. Okay, and let U vector is U1, U2, U3, and let V vector V1, V2, V3. So let me produce this mathematical expression. So let's try to U times W. Let's take a look at it. So first of all, we're gonna take a look at, I'm gonna make a little bit smaller. So let's do U times W equal to 0. So we're gonna multiply those two vectors. So which is U1, U2, U3 times W, XYZ. They must be equal to 0 if you multiply. So we know how to find, this is the cross product. So this is the cross product. I'm gonna highlight it. So that means cross product. So what does it mean? U1 times X plus U2 times Y, U3 times Z equal to 0. So we have one equation just found out. Second, I'm gonna make the same space. We're gonna do the second one, V vector times the W vector equal to 0. So the V vector, V1, V2, V3 times W, XYZ equal to 0. So this is also cross product, right? This is also cross product. So V1 times X plus V2 times Y, V3 times Z equal to 0. So we found out those are two equations. Am I correct? So I'm trying to solve for XYZ because I want to know what the W vector XYZ will be. Okay. So we have U1X plus U2Y plus U3 is equal to 0. And let's multiply. Let's say this is equation 1. I'm going to multiply here. What do you guys think? We are going to multiply V3. So therefore, if you multiply V3, it is going to be U1 V3 X plus U2 V3 Y U3 V3 Z. Okay. And then in the second equation, let's multiply U3 because I try to remove one of the term. So it's going to be, I'm going to multiply U3 into the second equation. So V1, U3X, V2, U3Y, U3, V3, Z equal to 0. So if I do this work, we have here. So the second equation, so here you multiply, and then second equation was this. I multiply U3, so now you have this new equation. So what happened? We can remove the third term. They're same, so when you subtract them, they're going to be gone. So what is the remaining stuff? You have X family, Y family, so therefore U1 V3 minus V1 U3 X plus U2 V3 plus V2 U3. And actually we are subtracting, this must be subtract because we subtract and Y equal to 0. Am I correct? So you can find out this equation from the system of equation rule. And then if I move this part to the other side, so basically U1 V3 minus B1 U3, it is equal to what? So there's X. This left side equal to, if I move to the other side, it is going to be, what do you guys think? It is going to be, so let me just double check. Yeah, so it is going to be, we have that information, and then we have subtract. So let me just, I think I have a little bit of missing information. So let me just highlight it. So this is X family. So this one times this is X. And then we are going to subtract this one minus that one. So if I combining like term, so if you think about it, this one minus that one. So I have a little bit of typo. This is still positive. This one should be negative. Are you following? So think about it. If you have a 2x plus 3 equal 3y equal to 0, 2x minus 3x minus y equal to 0. If you subtract them, it is going to be 2 minus 3x plus 3 minus 1y. So I'm going to just use that. I'm going to get rid of this one. So you can think about this algebraic work. So this one is this blue, right? Minus x combining like term, and then this minus combining like term. So I'm moving the green one to the right side anyway. So if I move to the other side, minus u1, because plus change it to minus, b3, b2, u3, y, they're going to be equal to each other. Are you following so far? Okay, hang in there. So what I'm trying to do is, I'm trying to know what the W vector will be, X, Y, Z. We are solving for X, Y, Z. So what does it mean? In this equation, I'm gonna copy this. Copy, paste. So from, from, I'm gonna highlight it, copy, and just get rid of it, and then I'm gonna paste it again. So we have, why? I think I'm not doing grouping, so let me highlight it. So copy, paste here. So we found out this one. So what does it mean? X, if you multiply X, if X is this, they're going to be same number. So if you have X, so this means X equal to, what is that? We just found out, U1 V3 minus V1 U3, that's X equal to this number. So therefore, what's going on? How can you solve for X and Y? So if you solve for X, Y, you're going to divide it by, so X is going to be, what do you guys think? We are going to this one divided by whatever we got the left side. So which is a U1 V3 minus V1 U3. Or if you feel like this is too much work, just simply this way. You have opposite. We are trying to solve for what the X and what the Y, right? So what is X? Okay, what is the X? X is going to be U2 B3 minus U3 B2, right? And then Y will be, we have U1 B3. Sorry, why? Sorry about that. I just made a big mistake. So let me just hold up here. We just want to know what the X and Y. So let me just think about it. We just found out this relationship. So let me see. I see where my mistake is. So this is a 2. Sorry about that. I made a whole mistake here. So let me rewrite it for you. So here one more time. So the left side, U1 V3 minus V1 U3X equal to minus, here we go. I wasn't confused. There's no 1. It should be 2. U2 V3 minus V2 U3. So that's what the relationship. So in other words, U1 V3 minus V1 U3, right? And then if you want, you can do distributive property. So minus U2 V3 plus V2 U3 Y. So therefore, X is going to be this, Y is going to be this. Am I correct? So we got the answer. So X is going to be, I can rewrite the relationship. So X is going to be minus U2 V3. Because if you multiply to each other, the opposite one, they're going to be equal to each other. So plus V2 U3. So I can change their order. V2 U3 minus U2 V3. And then Y will be U1 V3 minus V1 U3. So you can change the order, doesn't matter. So what is that? We have W, X, comma, Y, comma, Z. We just found out X is what? This one. Y is what? This one. And then if you do, keep on going, you know, use multiplying another one and remove another term. Likewise, you can find out the Z. But I'm gonna skip that work. Just I'm showing you the work, how we can solve for X, Y, Z. So basically, we are trying to use the given information. UW is a 0, VW is a 0, because that's what the cross product produce, the third vector. So we are trying to find out what the W. So from here, we got this 2 equation. And then by manipulating, we can remove the third term so that we were able to solve for what the X and Y. So that's what we got, X and Y. And likewise, you're gonna manipulate the equation, remove another term. Maybe you wanna remove the first one, and then you can solve for Z. So at the end, actually you're gonna find out W will be, okay, U2, at the end, you're gonna find out what we got. We got V2, U3 minus, I can change this order if you want. So V3, U2. And then you found out U1, V3 minus V1, U3. And then Z is going to be U1, V1. U1, V1 minus U2, V1. So that's actually what the X, Y, Z, the U vector, and then it implies that U is a perpendicular with the U vector, W is a perpendicular to V vector. So as you see that, it's very complicated to find out the W vector. But just remember, this is a very traditional way to find out the W's, which is this is a unique vector that is perpendicular to the each U and V vector, and then this is the algebraic work to find out the W vector. So which is a very, nobody gonna remember that. So I will show you the shortcut very soon. So what happened is this is the same as the U and W. This is the W vector. So actually we just found out this is X, this is V, this is Y, this is K. This is X, Y, Z basically. Okay, so just remember one thing is, this is your X, Y, Z. We just found out. And then in terms of the I, J, K, there's opposite, plus minus. I will show you why it is, okay? But I'm not gonna really use this one. This is too much work, right? So if you have a U vector, if you have a V vector, okay, I think I can find out W, but this calculation is very confusing. So before I'm gonna do the shortcut, let's really practice it, what they mean, okay? So let's take a look at the example. So in this case, I wanna find out U times W, V times U, okay? So let's do that work. So what are you guys gonna do? Step-by-step work. So first of all, U vector is 0 to 1, V vector 3, -0. So let's multiply U times V. This is a cross product, right? So this is a cross product. Dot product we are using dot. Cross product, we are using the multiplication symbol. So that's how you can figure it out which one is a dot and cross product. So let's do the cross product. That means you're gonna do, what are you guys gonna do? U times V. U times V. So according to the formula, ooh, this is a lot, right? So U times V, U2 times V3 minus U3 V2, comma, U3 V1, U1 V3, comma, U1 V2 minus U2 V1. So as you see that, this is a U1, U2, U3. This is a V1, V2, V3. So U2 is a 2 times, right? So what you guys are gonna do, it is going to be very, very confusing. So as you see that, this is very confusing and there's a high possibility to make a mistake, right? So anyway, 0, if you do that, U2 is this 2 times of V3 times a 0 minus U3. I know I don't like this work, but I'm just following that formula. And then V2 is a -1. So wait. U3 is 1. 1 times U2 is a -1. So this is X. I'm going to make it smaller. And then we have, the next one, U3. 1 times 3 minus U1. 0 times the V3, 0. Comma, the last one, U1. 0 times the -1 minus U2. 2 times the V1, 3. So this is your cross product. So it's going to be 0, double negative positive 1. And this is going to be 3. And this is going to be -1. This is going to be 0. This is a -6. So this is a U times V vector. One more time. We're going to do the backward. So I'm going to make it smaller. So in this time, we're going to do V times U, which is a backward. So what are you guys going to do? In this time, V times U, right? So if you are going to do, it's going to be, we're gonna change everything, right? So in this time, V2, U3 minus V3, U2, and V3. So I'm gonna change V3, U1. We have a V1, U3, comma. That's why V1, U2, and minus V2, U1. So let's calculate that. I know it's ugly, but we're gonna calculate it. V2, -1 times U3, which is 1, minus V3, 0 times U2 is a 2. So this is X. And then Y, V3, 0 times U1, 0, minus V1, 3 times U3, 1. And the last one, we have a V1, 3 times U2, minus V2, -1 times U1, 0. So this is the opposite vector. So if you calculate it, 0, -1, and -3, and then what you're going to get, this is a +6. So in this observation, we got U times V, 1, 3, -6. And the opposite, V times U, we got the similar number, but opposite. So what that means is, we just prove that U times W is the same as, sorry, not W, it's V. U times V, if you do the backward order, you have a minus in front of it. So this means that the cross products U times V and V times U are both orthogonal to U and V, but in opposite direction. So therefore, this property is you just found out. So let's take a look at it. We have u vector right there. We have a v vector right there. You multiply u and v, which is here. We found out the first one, 1, 3, -6. But when you multiply opposite, v and u, it's a different number opposite direction. So what does it mean? This is still orthogonal to each u and v, and this is also orthogonal to each u and v. So therefore, each u times v times u are orthogonal to u and v vector, but you have opposite direction because they have one is up, one is down. So this is a property 1. This property is number 1. Does it make sense, Gia? So we just prove this statement is true, and then we learn what they mean orthogonal, by using the cross product. Does it make sense, Gia? So a little bit of linear algebra concept. But again, I feel like Professor Van, this is too much work. Like, I feel like, I might be making a mistake. I might be, U2 and V3, the order is so confusing. I'm not going to memorize it. Yes, I totally get it, right? So therefore, I've been telling you there's a shortcut, okay? So what is a shortcut here? Do you remember the determinant in the metric system in linear algebra concept? So I'm going to show you that one. So finding cross product in 2 or 3 vectors, it's pretty complicated. Again, nobody gonna memorize this formula to find out the third vector, right? This is like so confusing. So therefore, we're gonna use determinant notation as an alternative way of cross product. So you may learn this metric system because a linear algebra is kind of like a required course before you are taking calculus 3. So if you remember the determinant, that's super easy to find out. So for example, you have a 2 vector system. So let's say you have a vector A, A1, A2, and then you have a vector B, B1 and B2. So as a vector, you can convert it to the metric system. So A1, A vector, V vector. So we have a 4 components. So this is going to be what? To find out the determinant, you're going to do the cross multiplication. So A1 times B1 minus B1 and A2. This is the A times B cross product. Simple, right? But what if I have a 3 by 3 matrix? So I have a 3 matrix, A vector, V vector, C vector. So this is the thing. You're going to have A1 to the front, A2, A3. And then you're going to make a mini matrix. And this one, if you choose A1, you're going to cross first and first, B1, B2, B3, C3, C2, and this is 1. Sorry, this is all made a mistake. So here, this is 1, this is 1, this is 2. So this one should be 1, 2. So we have a C2 and C3. And then we have A2. So then you're going to cross this one. And then the remaining B1, B3, C2, C3. The last one, you're going to cross this first and last. So B1, B2, C1, C1, C2, and remaining. And then we're going to beginning plus, minus, plus. So that's going to be your determinant of 3 by 3 matrix. So therefore, we can calculate it. So this one is going to be cross multiplication. So A1, B2, C3 minus, minus, what is it? B2, B3, B3, C2, minus A2, cross multiplication, B1, C3 minus B3, C2, plus A3. We have a V1, C2 minus B2, C1. So what happened? This number, B2, C3 minus B3, C2, B1, C3 minus B3, C2, B1, C2 minus C1. This is corresponding to the outcomes of the product, sorry, the cross product we just discovered. So let's go up, 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 up. So this number we just found out. These, let's go up, 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 up. You see that? They're corresponding, same thing. So same thing, B2, C3 minus B3, C2 we just got, correct? So they're all corresponding to the cross product. This is corresponding to the outcomes of cross product. So by using the determinant, you can find out the outcome of the cross product much easier. Does it make sense? So we're gonna use a determinant in 2.4 to find out the cross product outcome. Again, let's use the example. Quick practice. Find out the determinant of 3 vectors. So we have 2. So we have 1, 3, 3, 4 minus A2, 5. And then you're going to cross that, -1, 3, -2, 4, plus last one, 1, actually -1, and -1, 1, -2, and 3. So we're going to cross multiplication, 2, 4 minus 9, 5, -4 minus 6, -1, -3 minus -2. So if we would calculate it, 2 times -5 minus 5, +2 minus 1, double negative, change a positive, -1. So you should get -19. So this is a cross product outcome by using the determinant. Does it make sense? So much is simpler. So this is more shortcut. Okay, to find out the cross product outcome. So let's take a look at more in the vector system. So let's go to the same concept. So cross product can be calculated by a determinant. We just talked about it. So again, if you have a 2 vector, not 3 vector, so this is a 1, 2, 3, but I just have a 2 vector. I still want to find out the cross product outcome. In that case, the first row is going to be IJK because it's going to be standard. I means 1, 0, 0. J means 0, 1, 0. K means 0, 0, 1. Am I correct? So therefore, you could do the same equation. U1, so I is across U2, U3, V2, V3, and minus J, right? And then cross U1, U3, V1, V3. K, we cross that one, so U1, U2, V1, V2 remaining. So if you calculate it again, cross, to find out the determinant, I, U2, V3 minus, what is it? U3, V2 minus J, U1, V3 minus U3, V1 plus K, U1, V2 minus U2, V1. So again, this is your outcome. This is the product of cross, this is the outcome of cross product. So this is going to be your W vector. This is your W vector, which is U2, V3 minus U3, V2, comma. And we have a U1, V3 minus U3, V1, comma, U1, V2 minus U2, V1. So this way you can find out the W vector much, much, much quickly. Okay, so by using the determinant. Okay, so far so good. Okay, so therefore, this is the third vector, implies that W is perpendicular to U, W is a perpendicular V. So let's really do the problem. This problem, find out the PQ. So this is a cross product. So W will be P times Q. I'm looking for the third vector that is perpendicular to P and perpendicular to Q. So therefore, we have I, J, K, -1, 2, 5, 4, 0, -3. So therefore, you're gonna do 2, 5, 0, -3 minus J, -1, 5, 4, -3 plus K. So you're always opposite plus minus, K, -1, 2, 4, 0. So therefore, I will be cross multiplication, J cross multiplication, 0, 8. So therefore, let me minimize it. So there is going to be -6, I. This is going to be -17, positive 17J, -8K. So therefore, in this time, W is -6, 17, -8 vector. So this is perpendicular to P and Q each separately, respectively. Makes sense, right? So you can find out the W vector. Let me go all the way up. You can find out this W vector that is a perpendicular to U and V. And then we are not going to do this traditional way. This is like, oh my goodness, too much work. There's a high possibility to make a mistake. So please use a determinant, especially this slide. It's going to be much, much helpful. So if you have two vector given, I, J, K, and then one vector, find out the determinant. That's going to be your third vector. All right, one more example. Let's practice. So in this example, I want to find out the unit vector orthogonal to both A and B. So we know that. So actually this one should be U and V, my bad. So because a given vector is a U and V, right? So let's take a look at it. The cross product U times V is orthogonal to both U and V. Both the U and V vector, right? So that means, let's say let W equal to U times V. So it implies W is a perpendicular to U and W is a perpendicular V. So to find out the W, to find the W equal to, which is a U times V, we use a determinant. So we're gonna do the same work. W, U times V, U. So we have 3, I, J, K first, 5, 2, -1, 0, -4. So I, what? 2, -1, -4, 4, minus J, 5, -1, 0, 4, K, 5, 2, 0, -1. So let me minimize it. So now we can find out the W, so which means U times V, I cross product 8 minus 1, so 8 times minus +1 minus J, 20 minus 0, K minus 5 minus 0. So basically you're gonna get 7I minus 20J minus 5K. So this number, 7, -20, and -5, that's the W vector. Am I correct? Now we are specifically looking for unit vector orthogonal to both. So since this is going to be the orthogonal vector, so we're going to find out the unit vector simply. I'm going to make a space. So from here, we are going to normalize this W vector, right? To find a unit vector. So we know the unit vector formula in the same direction. So unit vector, if you remember, whatever given vector divided by each magnitude, the sum, you know, so if you remember u over this is unit vector. So therefore in this time we know that, so let me just get rid of this one. So unit vector formula is this. Yeah. So now your W is u times v, and then you're gonna magnitude of those is, you know, product. So we're gonna do this calculation. And then we already found out what the u times v, which is a w, that is a 7, negative 20, negative 5. We just need to find out the magnitude of it. So the magnitude, this, because this is your u times v. So therefore, 7 squared plus negative 20 squared plus minus 5 squared, you should get big number, 47.5. So we're going to divide it by 47.5. So therefore, the unit vector orthogonal to both the u and v is going to be 7 over radical this, negative 20 over radical that, negative 5 over radical this. So this is the vector orthogonal, the unit vector orthogonal to both the u and v. Does it make sense to you? So everybody understood, we found out what the w, which is a w is a u times v, but I want to find out the unit vector of that w, so that according to the formula, unit vector can be found out the given vector divided by its magnitude. So w is a u times v, which we got, and divided by its magnitude, you can find out this unit vector. All right, so this is how you're going to find out the, you know, the unit third vector by using the determinant again. Okay, so there's one more example. So I can show you, you can try that. So we already, u vector is a given, 1, 2, 1. V vector is a given, 3, 1, 2. So you can find out u times w, which is find out the orthogonal, that is u to u, or orthogonal with the v. So then you're going to find out the magnitude once you find out the w. Okay, so try this example. It's the same question. All right, now I'm going to show you all the properties of the cross product. So whenever I introduce a new concept, there are following properties, so please check them. So what is a property of the cross product? So we remember the first one is very, very important. If you multiply u and v, and then you change the order, multiply negative, because they're going to the different direction. So remember, this is opposite direction. That's why. So if you go up, one of the examples show you that proof. And then the next one, distributive property, same thing. You can multiply scalar, 0 is gonna be 0. And then one thing, if you multiply same thing in the cross product, it's going to be 0. So this is something new, number 1, number 5. So check it out, and the order doesn't matter if you multiply, you know, the order. So that's the cross product so far. All right, so far we understood the concept of the product, you know, cross product. Now I'm gonna show you all the applicational problem where you're gonna see the cross product more and more. So one of the example where you're gonna use a cross product is to find out the area of a parallelogram. So let's take a look at that example. So, you know, if we have a square, length times the width is gonna be the area of the square, where circle is a pi r square. But what if I have, right? What if I have a parallelogram, which is not like, height is not really given. So let's say I have the parallelogram image. So let me redraw. So I have a parallelogram, looks like this, okay? So let me redraw. So we have a parallelogram. So the parallelogram, let's think about it. We have a two vector. One is here. Let's say this is a vector A. And then I have a second vector B. Okay. And then let's say they're creating the angle theta. So in the parallelogram, if you can find out the height, which we don't know, this is the height. Height times the bottom vector, you can find out the area of the parallelogram, correct? So that's the way you can find out the area of the parallelogram. Base times the height, right? So the base is a given. This is the base, the B vector. How can you find out the height? So according to SOHCAHTOA, did you guys see here, there's a right triangle? So there's an angle. So height, so this is going to be the hypotenuse. And this is going to be the opposite length. This is the adjacent. So height is going to be, think about it, SOHCAHTOA sine theta is opposite over hypotenuse. Opposite is the height we are looking for. Over the hypotenuse is a vector A. So what does it mean? Here we can think about sine theta is height over A vector. If you do the cross multiplication, height is basically sine theta times A vector. In other words, sine theta times the magnitude of the A vector. Does it make sense? So therefore, we found out the height. Height, I'm going to change this order. A vector times the sine theta. And then we are looking for the B, which is the length magnitude of the B vector. So therefore, area of a parallelogram, A magnitude times whatever the given two vector, and then sine theta. This is the parallelogram, to find out the area of the parallelogram formula. Does it make sense to you? So therefore, textbook is introducing. If you already know what the two vectors, okay, that's good. Just you're gonna use a cross product and multiply and find out the magnitude. Or this is also same as each magnitude times the sine given theta. So you have a two-way to find out the area of the parallelogram. So let me write it. One is just simply two vectors cross. This is magnitude of cross product of two vector, or we just prove that each vector is a magnitude times the sine theta. So you have a two-way to find out the area of the parallelogram. Does it make sense to you? Okay, so let's take a look at the example. It's a very, 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 very fun topic. So here we go. I'm gonna copy this, copy. So we are trying to find out the area of the parallelogram. All right, so let's example. We have ABCD parallelogram. A is here, I don't know, A is here, 0, 1, 3 vector. And B vector, let's say here, 1, 3, 5, and C should be here, 5, 7, 5. If you want to change the order, that's fine, but I'm just using this order, and D is 4, 5, 3. I want to find out the area of the parallelogram. So since we don't know the angle, since we do not know the angle between any two vectors, the number two formula does not work, right? The number two, because we don't know the theta. The theta was not given. So thus, we're gonna use the first formula. Just as long as you know the u, the length, one of the vector, and then the other vector, just cross product. So therefore, let's say this is the A, this is a vector U. Let's say this is a vector V. So U vector, we know that the length between A and B, correct? So it is going to be 1 minus 0 and plus, what is it? 3 minus, so not plus, my bad. 1 minus 0, comma, 3 minus 1, comma, 5 minus 3. So which is 1, 2, 2. So we have U vector is 1j, 1i, 2j plus 2k. So this is the U vector we found out. Same thing, I want to find out the V vector, which is the length between A and B. So 4 minus 0, comma, 5, 1, and then 3 minus 3. So which is a 4, 4, 0. So the V vector is a 4i plus 4j, because the 0 is a 0. So now we have a U and V. All you need to do, just do the cross product. So we need to find the area of the parallelogram is going to be U times V, because we don't know the angle, we cannot use a second formula. So by using a determinant, we can find out what happened. This U times V, I, J, K, and the U vector is right there, V vector right there. So U 1, 2, 2, 4, 4, 0. So we know I, it's too big, so I'm going to minimize it. So I 2, 2, 4, 0 minus J 1, 2, 4, 0 plus K 1, 2, 4, 4. So let's calculate it. I 0 minus 8, J 0 minus 8, and plus K 4 minus 8. So negative 8i, negative, negative, positive J minus 4K. So we found out U times V, which is negative 8, 8, negative 4. So this is U and V more cross product. But we are looking for the magnitude. And then negative 8 square, negative 4 square. That would be 144, which is a 12. So this is the area of the parallelogram we just got by using the first formula. So still we use a determinant. Okay, if the angle is a given, right? So 2 vector, and then angle is a given, second formula will be much gonna be faster. But since the angle does not given, so we don't know, so we can just use the first formula. So that's how you find out the area of the parallelogram. Still we use the cross product. So this is one of the application. So let's take a look at another application. Let me go down. Here we go. Okay, so we want to find out the area of the triangle. Okay, so we want to find out this area, but what is the characteristic of the triangle? So triangle, area of triangle, do you remember? It's a half of parallelogram. Why? Because if you have, make it longer, and here, this is a parallelogram, half of the parallelogram, gotcha, it's a triangle. So in this question, once you find out the 2 vector, because we don't know the angle, you're going to find out the area of the parallelogram. So let's say this is a U vector, this is a V vector, U times a V, and magnitude, this is area of the parallelogram. Then triangle, the area of triangle is going to be 1/2 U times V. Okay, so it's the same question. I'm not going to do this one. You can try it. Once you find out the area of the parallelogram, half of it. So you can find out the U vector, which is the length between P and R. you can find out the v vector, which is a PQ, correct? The length of the PQ. And then once you find out each U vector and V vector, use a cross product, right? So which is IJK, and you're gonna have the U and V vector. Find out, and then later you're gonna find out the magnitude of it. So you can try this question. Definitely it's not complicated at all. It's the same question. I already show you how to find out the area of the parallelogram. So once you find out the area of the parallelogram, half of it, you're gonna find out the area of the triangle. Okay, so try this. And then there's one more example. You can try this as well. Find out the area of the parallelogram and half of it. So number 8 and 9, you can definitely try that question. All right, so I show you so far like one example where cross product can be used. Especially we can find out the area of the parallelogram by using the cross product right there. Right, so in this time, using the determinant, we were able to find out the cross product outcome. So let's keep going. We're gonna keep building the more and more applicational problem. But before we're gonna get that, let's take a look at just quick characteristic of the scalar. So if you have 3 vector U, V, W, and then you want to find out the product of those 3. So when you have a 2 vector, we use IJK. Right? And then if you have a U vector, U1, U2, U3, and you have a V vector, V1, V2, V3. So we were able to find out what the cross product of those 2 vectors. But what if I have a 3? Okay, and then let's assume one of the vector is a scalar, which means you can do the distributive property. It's nothing is confused, just set it up. U vector, top, U1, U2, U3, V vector, V1, V2, V3, W, and then you do the same thing, the determinant again. So then set up this way. And then use or find the determinant. That's it. So U1, same thing, U1, V2, V3, W2, W3, minus U2, V1, V3, W1, W3, plus U3, V1, V2, W1, W2. So same way, although you have a 3 vector. I show you actually at the beginning. So 3 vector doesn't matter. You can find out the cross product by setting up each vectors horizontally. So we call also one of the vector is a scalar because this is can be distributive property. So anyway, let's take a look at the example quickly. Okay, UVW, they are given. So we want to find out all the multiplication. So this is a scalar because you can use a distributive property. So V vector can be stretched or shrink down, or W can be stretched or shrink down. But anyway, we are multiplying all together. So in this case, just set it up. 1, 3, 5, U vector, V vector 2, -1 and 0, W vector -3, 0, -1. Okay, so that you can find out the same information, the determinant. We're gonna do the determinant of 3 by 3 matrix, so you can find out the answer as well. So I'm gonna leave this one because we've been practicing a lot. So you can do like 1 minus 3 setup, 5 setup, and find out the answer. Okay, so try this as well. Just I want to show you how to find out the cross product outcome when you have 3 specific vectors. So why am I showing you this one? Because this is skill gonna find out the next concept. So the next one is more important. So we know how to find out the area of a parallelogram. So if you remember, the area of the parallelogram, let me copy paste. So we know this one. This is area of the parallelogram. So we use either this formula or that formula. How about the volume, which means This is the two-dimensional space area parallelogram. But what if I have three-dimensional, the volume? I want to find out the volume of this parallelogram. So I'm going to write a couple things. First, what we know, the area of the base, which is this shape. This is the base of the parallelogram. In other words, area of the base, it means area of the parallelogram is given U times V, cross product and magnitude. And then to find out the volume, once you have a base, you need a height, right? To find a volume of a parallelogram, we know base, which is the area of the parallelogram times the height. We need this information. So we already know the base, which is the area of the parallelogram, and how to find out the height. That's a question mark. Because in the parallelogram, this is not really the true, this is not the true, this is not the height. This is not, oopsie, this is not height we're looking for. Height should be straight line. So how to find out the height? Okay, so I'm gonna write it. The height, okay, the height is going to be the project, right, of U vector. So you see that the height here, this is a true height. This is your true height. You have a U and V vector. Sorry, my bad. So we have a U, sorry, this is a V, this is a W vector from the base. And then the multiplication, this two. So the project of U onto V times W is going to be the height. So which is this height. This is the area. The true height, so which means this is the project vector, right? This is a vector projection. You remember last time. Onto where? U time onto U. So this two multiplication onto U, that's gonna be the height. So that's a mathematical. So you think about it, there's a two, I don't know, like item, and then you want to find out the shadow, which is you have two lights, and then there's a item, the shadow is gonna be here. So this is the height. So the basically project vector of U, sorry, oh my bad, project, I made a mistake, so it should be the opposite way. So project of, let me double check. Yeah, project of V times W onto U, that's gonna be the height. So basically we know how to find out the project vector. So let me just minimize this one a little bit. So basically what happened? The volume of the parallelogram is going to be the length of the height times the length of the base, the area of the parallelogram, so it's not gonna be this. We already know the base. So in other words, height, we write it, project V times WU times base is U times V. Am I correct? And then let me just keep going. Do you remember the project? The project, the vector projection formula, it is going to be, so project V times W onto U, that means U times V times W divided by the magnitude V times W. That was the formula. And then we are multiplying U times B, that's the base. So they're gonna cancel. 1 second. I made a mistake. So we have a U times W, so not the U times B. This is W. So they are canceled anyway. So the project we got that one. So the volume, the finally, is going to be U times V times W. So which we know how to calculate it. So this is the same. So the volume of the parallelogram is basically you have a 3 vector and then find out the cross product outcome. So this is the proof stuff. So don't worry, you got this one. The area of the parallelogram, we have a 2 option. We are not looking for area, we're looking for volume. So that should be, the base times the height. So the base is, we know this is area of the parallelogram. So which is this. And then this height, what does it mean? This is a vector projection, which is a project of V times W onto U, so that according to the vector projection formula, we got this one. And this is the base. They're going to cancel. So basically volume is going to be find out multiplying all 3 vectors. That's it. Okay. So let's do the question. So we now prove that. We just prove this is true. This is the volume formula. So according to that formula, we want to find out the volume. That's it. So we already have 3 vector. What are you going to do? Volume A times B times C. So A is a 2, 1, -1, 3, 0, 1, 0, 1, 1. So you can find out. Same thing, using a determinant, you can find out the answer. That's your volume. So try this. So the calculation is not really complicated at all. If you understand the concept, why this is the volume formula, because we are doing, base times the height. So this is the formula from, the height and base. So it's cancel. Volume is basically you're multiplying 3 vectors. So we are using the determinant to find out that. So that was another example where you're using the cross product. So not only the area of the parallelogram, but also volume of the parallelogram. Okay. Last application, hold up there. The last one is right there. All right, what is this? So last application where you're gonna see the parallelograms. The cross product application. So let me read it. Application of the cross product, torque. So this is the language terminology. So let me read it. If we tighten a bolt by applying a force to a wrench, so you're trying to tighten your bolt, you need a force. And then if you're producing a turning effect, so because you are not going to be just push or pull, you have to actually rotate it. So that force we call torque. And then denoted by that symbol that acts along the axis of the bolt to move it forward. Okay, so torque, this is the Greek letter. And then it is a tau, tau, that's the Greek letter. So measures the tendency of a force to produce a rotation about the axis of the rotation. Does it make sense? So you have a bolt here. You're trying to make it, tight so that you have to have a length of the bolt. And then there's a force opposite way. And then if you multiply the length times of the and the force, that power we call torque, and then it is going to be R times 4. It's not that complicated, right? Does it make sense? So let R be a vector with the initial point located on the x-axis of the rotation and with a terminal point. So this is all vector R, and there's a force vector. If you multiply those 2 vectors, boom, 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 you can find out the torque that you can tighten the bolt. And then how to find out the magnitude of the torque. It is going to be magnitude of each vector's magnitude, and then there is also creating the angle. So if you know the angle, you can find out the length of the torque. So the length of the torque, magnitude of the torque, it is going to be R magnitude times the force magnitude times the sine theta. So that's going to be the torque. So this is where you're going to use the cross product. I will show you very soon. Okay. And then this is from the, we found out the very similar formula in the above. So just be aware the unit of the force, distance, and work. we are using foot or meter. We are not using centimeter for the distance. Just be aware. So let's take a look at the example. So remember this formula, and those are two. All right, here we go. This is a real problem. I really want to do it. A bolt is tightened by applying a 40 Newton. This is a Newton, so this is a force. So you have a force, this is a Newton, and then 0.25 wrench as shown below. So they have, this is a 2 meter, of course, because we are using only the meter for the distance, or foot. Find the magnitude. And then the given angle here, let's say this is a 25. So what would be this angle? 90 minus 25, it is a 75. So we have everything. The magnitude of the torque, it is going to be R magnitude times force magnitude times sine theta. Everything is a given. The length of the R, the magnitude is a given. Force is a given. So you multiply those two times sine, the between angle, force and, the R is a sine 75 degree. So you can calculate the decimal. It's about 9.66. And then the unit is going to be, this is the meter, this is the Newton. So meter times a Newton, it's going to be joule. So therefore 9.66 joule, that's the answer of the torque. Okay, the work. Newton times a meter, that's a joule. So if you know that formula, it's a pretty simple, and we talk about it's a similar from the other applicational problem. So one more example. So same thing we know. I'm gonna just copy that. Copy the magnitude of the torque. Calculate the force. In this time, they want you to calculate the force required to produce 15 and Newton times a meter. So this means what? This is already the torque. This is a torque of torque. And they're creating the 30. So what happened is, and then 150 centimeter, be careful. We have to convert it to the meter, so 1.5 meter. So we know this is a 15. Actually, this is a joule, but Newton times a meter equal to length. The R rotation 150, which is a 1.5 meter, and we are looking for force and sine 30. So what happened? We are looking for this. So F magnitude will be 15 divided by 1.5 times the sine 30. So you can calculate it, meter cancel. You can 15 divided by 1.5 times the sine 30. You should get about 20 Newton. This is the force. So calculate it, okay? So that you can find out the answer of the force. So sometimes, they might be looking for the R, they might be looking for the torque or angle. Try in many ways. So last example, I'm not gonna do it. Think about it. You know this, okay? Everything is a given. The R is a given. I can see you. I can see the length, angle. I can see the force. Find out the magnitude. So plugging in, and you can find out the answer quickly. So that's all about it. 2.4. So I'm not, doing any fancy work here. Pretty much is an understandable topic. So go over what the definition of the cross product, right? When you have a 2 given vector or 3 given vectors, and then think about using determinant to calculate a cross product. And then be careful when it is, what does it mean orthogonal? In terms of the cross product, you're looking for the third vector that is a perpendicular to each 2 vectors. And also we found out in a couple, applicational problem in terms of using cross product, find out the area and volume of the parallelogram. And also last one was a torque of the given force and given position. Okay, so that was all about it. 2.4. I hope you guys enjoy watching this video. And now you can, read textbook if you need more practice. There are much, meaningful information you need, but my lecture is pretty much extract idea so that you can, you can study more efficiently. There are more videos you can watch in each quiz. Feel free to participate in the chapter, and if you have any question. So we have a lot of resources available for you. Please use them. And I will see you guys in the next video. Thank you, everyone. Bye-bye.